Hello, my name is Radu Boncea from the National Institute for Research and Development in Informatics, ICI Bucharest. Um, ICI has quite a history in terms of research in this country. I mean, it's the institute that brought the internet in this country. And my presentation is related to building a research infrastructure a safer way, uh, keeping in mind that a modern approach would involve the usage of artificial intelligence and so on. Um, so I run the Department of Software and Complex System Engineering. And one of the tasks we have, or we had, last year we had a project to develop internally some innovation labs addressing some of the recent advancement in IoT, for example, augmented virtual reality, blockchain, artificial intelligence, 5G communication, high performance computing, and digital forensics. So we have this project which ran until recently to establish all these innovation labs. So also we had some quite high level requirements for this. I mean, all these labs should have been. Okay. I have a small problem with the PowerPoint. So the high-level requirements that we had was for each innovation lab, it should support an agile environment. We had different teams that are using these laboratories, and there is a need for a cross-team collaboration. Um, sorry. I will try not to run as a slide. I don't know why it doesn't work. So we have different teams internally from ICI, but also at the European level and international. We collaborate with teams from United States, South Korea, and most of the European nations. So they have to have access to our infrastructure. Those laboratories should support a multi-dimensional technology stacks and tool sets. In IoT, there is a need for different tools, different from I don't know, from what artificial intelligence laboratory are using or digital forensics. So they have different kind of requirements. Also, the users or the members of the laboratories have different experience levels. So like we have interns, but also like 20 years or more senior researchers and developers. And there is also there are multiple stakeholders involved with different interests and sometimes divergent interests. ICI is under the coordination of General Secretariat of the government. So there are like ministries involved, there are companies involved, and there are other research institutes involved. Another requirement would have been to have all this laboratory set up in a safe manner because there are sensitive data at work, and we need to store this data in a safe way. There's also a problem of the system should be auditable. So there should be some kind of journals that record any movement on touch on the data, and should be restorable. By restorable, I mean like at infrastructure level. Uh, for example, virtual machines or containers should be restored if something goes wrong. Um, Another high-level requirement would be to be economically viable. So to support all the this laboratory are intended to support activities in research, innovation, and development, but also to support operations of different solutions that we develop, and should be sustainable, like easy to maintain, easy to extend. Now, if we go down with the requirements on a much lower level, um, all this laboratory should support self-provisioning of resources and services. So like we have a bunch of physical servers upon which we run Proxmox for virtual machine virtualization. We offer Docker and Linux containers. So we have as a solution, we use Docker Swarm and Portainer. All laboratories should have access to different kind of databases and different kind of setups for these databases, like it's a single instance database or it's a cluster database, and should support different kind of databases like document-oriented database, time series database, structured databases. In research also, most of the researchers are working with virtual environments for Python, for instance. So there should be a way for these researchers to set up their own virtual environments on this infrastructure. So for that we are using a Jupyter Hub, which it's something built on top of a Jupyter Notebook. There should be collaborations tools. So here we have quite a lot of collaborations, from ticketing support systems to Plug and Meet, which is our own way of doing WebEx, project management tools, and code repository. Another low-level capabilities that should be offered, it's automation and orchestration. So for that we are using, for instance, a lot of Ansible playbooks, continuous integrations, and we monitor everything at infrastructure level with Prometheus exporters. Prometheus, we are using our own system information, security information systems. We are using Elkstack, for instance. All authentication and authorization in the infrastructure should be done as much as possible using single sign-on. So for that we are using an identity server. So our vision is a member of a laboratory should access an application which we called homepage, and this homepage access is authorized using an authentication mechanism provided by an identity server. So once the user gets this authorization, he would have access to particular tool sets that are configured for that particular user. So like I said, the collaboration and productivity tools, the virtual environments, databases access, and virtualization tools. All on this which rely, as I said, on Proxmox and Docker swarms. And which then are based on a physical level on machines which we are called nuke. So to test all this, we kind of set up our own environment. So we are calling this setup hyper-convergent high-performance computing. It's not actually very high-performance computing, but it does follow the definition for this. And it does also follow the definitions for hyperconvergency. In this image, for instance, these are called NOCs. It's from Intel NOCs, next unit of computing. And these are Intel NOCs Extreme. They are mainly used for their way of supporting GPUs, including the fact that we can have multiple GPUs to each of these servers. So this is just a small server that could potentially, just a small solution that could potentially scale horizontally with different infrastructure elements. So it's quite hyper-convergent. So our homepage would look like this, just to make it a little big. So it would look like more like this. So once a user logs, based on his profile, certain applications are available for him. So for instance, if you use Jupyter Notebook, okay. So if you would like to use Jupyter Hub or Jupyter Notebook, he will could enter that application. The design, as I said, is quite simple. The user enters this homepage. He will authenticate against an identity server. The identity server will pass a token. That token will be then used across all his sessions and all the applications, which are basically open source applications that we are using. With small adjustments, they will check this token for access. For that, we had to actually build a tunnel. So all the requests to this application are run through a tunnel that will actually check that token, because otherwise it would be difficult to modify all the applications. So it's based on a zero trust, similar to Cloudflare. We are using open authentication, also Linux Active Directory, and we, for instance, log all authorization and authentications. So one of the things of the requirements was to be safer. So because there are many people that are using those applications and from different institutions, one way to achieve this is to make use of already gathered data that we have, like all the logs from the system information systems, from Prometheus. So we get all the data, all the metrics regarding operation system running performance, the metrics about the application, and we kind of try to analyze all these time series using different methods, statistical methods, machine learning methods, and deep learning methods. And then the results of this analysis could be feed into a model such as a generative pre-trained transformer. Like, for instance, we are using Llama Index and recently Llama 2 to generate reports and summarizations of of whatever happens in the system. And then we proceeded to automate and do an integration for sending alerts based on these reports. And then the final point is something that occurs recently, and we are working on it, is to include GPT agents in this analysis. And to show you exactly how it would work, it's, for instance, if GPTs are extremely powerful at not only summarization, but they have a certain ability in there when they predict the sequence of tokens to actually have a somehow rational thinking, I could say, which is a little bit unexplainable. But so we for instance, given a system prompt to GPT where we tell him, you know, your role here is to interpret application logs. Specifically, you'll be focusing on authorization logs for a particular user identified by. Remember, these system prompts are automatically generated for this particular user. So, you know, this user has a certain schedule, or is working on a fixed schedule, like Monday, Tuesday, and Wednesday from 8 to 5 o'clock, and Thursday and Friday, you know, from 12 and until 8 p.m. So any other usage outside these intervals should be considered unusual and flagged. So then we feed him with what would look like logs from our application, like we have the timestamp, the application responsible for this, so for instance, in our case, the access tunnel, and some simple log like, you know, user identify with the ID is granted access to application ID 1. And the GPT would say the provided logs display, you know, it's kind of say that the usage is unusual based on the user ID schedule. And they give me some good explanation. The user is accessing application ID 1 and application ID 2 at a certain hour that it's outside the schedule. And another point he makes, it's since the log is for a later hour on a weekday, it should indeed be considered an anomaly according to the schedule. So the logs, however, it's also about another user ID here. User ID 222. So we have two users here. So I try to, you know, make him to see if he actually gets that part. So he writes me that it is worth noting that the access granted to ID 2 is not relevant to the anomaly detection for ID 1. So basically, he knows to ignore certain things. So he doesn't need to be pre-programmed for that. So, like I say, why GPTs is because they are exceptional at inferring the tools needed. So we are using LangChain for that. Day by day, we see an increase in the context windows. Right now, I think GPT 4 Plus has almost 200,000 tokens, which kind of exceeds Claude 2 from Anthropic. We can now use local memory, like an operating system. So we are not using all the context windows, but like certain things, we can save it locally. So for that, we are using MemGPT. And of course, we can profit or piggybacking on the fact that open source is catching up somehow with OpenAI. So we have recent models such as recent models like Llama Index 2. So we are embarked on this GPT agenda. So we think we should migrate to GPT agents. So there are three things here that should be underlined. Is that using GPT, you make application knowledge base. So you already perhaps have a lot of data. You have an input to feed in available at your disposal, like syslog applications and time series. And of course, you could build multiple agents that, I don't know, send alerts and orchestrate things, but also most important, agents that could improve other agents on the fly. Like in the example, to improve the prompt. So as a roadmap, we expect in the following months and years, more like months, expect for the multimodality of OpenIE, there where we can process image, video, and sound. And for that, we have our own sensors. We try to use open source as much as possible, like Llama 2. We want to integrate more tools and develop models for generative informations using fine-tuning or prompt engineering. And we want to get physical with building more sensors to also monitor the physical environment of such laboratories. Okay. Thank you. If you have any questions.